What we're doing today, ladies and gentlemen, is simplifying radicals. It's not like yesterday. You don't just stick them in your calculator. That is not how we're doing this. Simplifying. The simplest form of a radical expression is an expression that has no perfect square factors other than one inside the radicate. No fraction in the radicate and no radicals in the denominator of the fraction. Product property of radicals. The square root of a times the square root of b equals the square root of a, b. Quotient property of radicals. The square root of a over b equals the square root of a over the square root of b, where a is greater than or equal to 0 and b is greater than 0. So what we're doing today, ladies and gentlemen, is dealing with a lot of things with perfect squares. So you would want to write this at the top of your paper. Perfect squares. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. 8 times 8 is 64. 9 times 9 is 81. 10 times 10 is 100. 11 times 11 is 121. And 12 times 12 is 144. So at the top of your paper now, you should have those written down. You're going to use them on your homework and to do these problems. So the first thing we're going to do is we're going to look at the square root of 50. What we're going to do is find two numbers that multiply to give us 50, where one of them is a perfect square. So hold on, Ryan, you can do the next one. The first thing you're going to do is you're going to start at the biggest possible perfect square. Now, you know, none of these are going to work because they're bigger than 50. 49 does not go into 50 evenly. 36 does not go into 50 evenly. But if you took out your calculator and did 50 divided by 25, you would get 2. So now we're going to put underneath the radical 25 times 2. And then if you look at up at the top where it says a square root times b square root equals the square root of ab, we're going to separate these. The square root of 25 times the square root of 2. We're doing the opposite of this right here. What is the square root of 25? Please raise your hand. Yes, Tiara.
This is the answer, but I'm just asking. Like, could we done like 5, square root of 5 times 10?
No, because neither of those are a what? Right. Yes, Delshawn. It's 5. So we get 5 square root 2. And again, I'm going to repeat what Tiara just said because it's a really important question. She said, could you have used 5 times 10 under the square root? And the answer was no, because neither of those are a perfect square.
What if you run into the problem that you can't find one that's a perfect square?
Then it's in its most simplified form. Okay? All right, let's look at the square root of 48. What two numbers where one of them is a perfect square goes into 48 evenly? Ryan, you told me you were going to answer this one. What two numbers multiply together to give you 48? Okay, yes, Jordan.
Oh, once we get to 5.
Yes. That's the answer. You're finished. Yes? 4 times 12 is good, but is there a perfect square that's bigger than that goes in there? 9 doesn't go to 48 evenly. 16 goes in there how many times? 3.
I have a question. If you do 12, is that wrong?
The reason it is because it's going to cause you more work done. If you did 4 and 12, and then 12 can be simplified to 4 times 3, which then can be simplified to 2 square root of 3. So it's going to take you longer. So that's why we start at the biggest one and work your way down. Okay? All right. So now I separate them. I've got the square root of 16 times the square root of 3. What is the square root of 16?
4.
So we get 4 square root of 3. Okay. I'm going to give you just about a minute. I want you to try the next two on your own. Remember, you're starting with the biggest square root you can find and working your way backwards. Which one goes in there evenly? So looking at 12, what's the biggest number that's a perfect square that goes into 12 evenly? Don't say it out loud. You try that. Then whichever one's a perfect square, you take that answer and put it on the outside. 2 square root 3. Okay? Some of you tried 2 times 6. Neither of those are perfect squares, so they won't work. Don't forget that. All right, we've got the square root of 32. So again, you'd look at your perfect squares and you'd go all the way up. 25 doesn't go in there evenly, but 16 does. So you get square root of 16 times 2. So you get the square root of 16 times the square root of 2, which gives you 4 square root 2. Let's turn it over and look at the back. We're actually going to skip A and come back to it. We're going to do B first. And we're going to skip the C completely. You can cross C out. Okay. When we have a fraction, we simply take the square root of the top over the square root of the bottom. Okay? And then you just, where that line is, you put the square root of the top, square root of the bottom. The square root of 4 is 2, and the square root of 25 is 5. Done. That's it. Now we're going to do the next ones, which are hard. Okay? Don't worry about this right now. Do this right now. We've got the square root of 32 over 50. So the first step is to separate them. Square root of 32 over the square root of 50. Yes? So I get the square root of 16 times 2. And what do I get in the bottom? 2 times 25. I get the square root of 25 times 2. Now the square root of 16 is 4. So I get 4 square root 2. And the square root of 25 is 5. So I get 5 square root 2. But if you remember from the vocabulary in the front, we are not allowed to have square roots in the denominator. So this is tricky, so please watch. This is how you get rid of them. I'm going to multiply the top and the bottom by the square root of 2. Okay? So what you're going to do is just multiply the numbers inside the square roots. So I get 4 square root 4 over 5 square root 4. What's the square root of 4? 2. So I get 4 times 2 over 5 times 2. So I get 8 over 10, which reduces to 4 fifths. 4 times 2 is 8, 5 times 2 is 10. So that's how I get 8. I got 10. All right, ladies and gentlemen, we're going to try some more where we're simplifying the denominator. We're going to get rid of the square root on the bottom. Okay? Let's look at,
Always multiply by 2.
nope, whatever's inside the square root side. And we're going to do one of those problems right now. We've got the square root of 118. So first we're going to have the square root of the top, square root of 1, over the square root of 18. What is the square root of 1? Yes. 1. And then 18. So I'm going over here to my perfect squares, and the biggest square root that goes into 18 evenly is 9. So I get the square root of 9 times 2. Okay? And then I know that the square root of 9 is what? Yes, Kenny. Because 9 times 2 gives you 18. So I get 3 square root 2. Can we have a square root on the bottom? No, what's inside that square root sign? That's why I multiply the top and the bottom by the square root of 2. So I get the square root of 2 over 3. What's 2 times 2?
4.
4. So I get the square root of 4. And what is the square root of 4? 2. So I have the square root of 2 on top. I get 3 times 2 on the bottom. And 3 times 2 is? So square root of 2 over 6. Okay, let's look at the next one. The next one's easier. We had the square root of 1/3. With fractions, the first thing you do is separate them. Square square root of 1 over the square root of 3. What times what gives us 1?
1.
1. Can I have a square root on the bottom?
No.
So I'm going to multiply the top and the bottom by square root 3, because 3 is what's inside my square root. So I get square root 3 over the square root of 9. And what's the square root of 9?
3.
Square root 3 over 3 is your final answer.
Okay.
We're going to do the last problem and then we're finished. Okay. The maximum speed s in knots or nautical miles per hour that certain kind of boats can travel can be modeled by the quadratic equation s squared equals 16 over 9x, where x is the boat's water line length in feet. The water line of a boat is the line on the main body of the boat that the surface of the water reaches. Use this model to express the maximum speed of a sailboat with a 32-foot water line in terms of radicals. Then find the speed to the nearest 10. So what we're dealing with is s squared equals 16 over 9. X is the water line, so that's 32. If you have something squared, how do you get rid of that little 2 that's squared? What do we take? What we've been doing the whole week. Square roots. So we square root both sides. So we get s equals the square root of 16 over the square root of 9. I'm just simplifying that stuff real quick. Times the square root of 32. What is the square root of 16 over the square root of 9? 4/3. Now we've got to simplify the square root of 32. What's the biggest perfect square that goes into 32?
2 and
2
16.
and 16. Thank you, Nathan, for raising your hand. I didn't see. What is the square root of 16? So we get 4 square root 2. And then I'm simply going to multiply these two things together as if there was a 1 on the bottom. So I get 16 square root 2 over 3. So that's your first step. You have to have 2 answers for this one. This is in simplified radical form. Now I want to find it in decimal form. So this is where you take out your calculator. You have 16 times the square root of 2, and then divide that by 3, and we're going to round it to the nearest 10. So it should be just one decimal place. So s equals